Perth Linux Users Group, talking Linux and open source.
Talk tonight is on Subversion, not because I think it's better than Git, but because I think it's presenting an alternative that might be the right tool for the job in some cases. Okay, this was working a sec ago. All right, let's try this. Okay, oh, yeah, that's the contents for the slides. So we're going to take probably about 45 minutes to an hour, and if anybody's got a laptop, they're more than welcome to play along. So this is pretty much a beginner's introduction to Subversion. If you know Git, this may also be of use to you because Git and Subversion work differently, but they're similar enough that it's annoying. All right, so I mentioned using the right tool for the job. Now there's several distributed version control systems. They've cropped up in the open source sphere because people found it really useful when sending patch sets all around for people to be able to integrate stuff that other people have done without everybody having to work from the same central repository. So Git is one of the most famous ones. Mercurial is also supported by certain DVCS hosting places like Bitbucket. GNU Arch is actually quite an old one, and Monotone, there's one of the guys in the UCC who's involved in that project. He's the guy, Matt Johnston, who wrote Drop Bear, which means, you know, if he's on that project, it must have something to say for it. So moving along, there's several ways in which a revision control system can track revisions, but before I do that, is there anybody here who's not familiar with the concept of revision control systems, also known as version control systems? Right? Since everybody appears familiar, I'll move on. The old revision control system was not based on repositories at all. You actually had a directory which had your, I guess you could say your repository in it, and it was per file, and every file had its own revision. So you might have a whole directory tree, every file in there would have its own revision, and keeping them all synchronized was quite difficult. I believe that's the same model used by CVS, which was the network version of RCS, but a lot of people found that CVS was inadequate and hard to work with, and so they moved on to more modern systems. And Subversion is an example of something which is a more modern system. Whenever you have a repository, it has a version that the repository is at. Now you might think, well, I might not want all the files from the repository to all be in my working copy at that revision at the same time, and you don't have to, but I guess you just need to know that whenever you do a commit to the repository, no matter how many files you commit or where you commit them from, it increments the whole revision of the repository. Now I'll talk a bit more about Git because commit IDs are how Git does things. Whenever you make a commit to certain files, that bunch of files that you're committing has a unique ID that it's associated with it, and there really is no notion of file revisions or repository revisions. You're just talking about individual commits are the unit of I guess currency or whatever in Git. So yeah, Subversion uses one repository revision, and whenever anything gets checked in or committed, that repository revision increments. It's an integer. Now, Subversion's actually quite a simple system internally. It uses objects to keep track of files, but not in the same way that Git does. It's more akin to the old systems where it keeps the current version of the file and deltas for past versions. Whenever you want to do branching or tagging in Subversion, this is done using simple copying. And whenever you copy a file from one place to another in a Subversion repository, you're not actually copying all the data, you're getting a reference to the objects that are behind the scenes. So it is efficient. You can make as many tags as you want, or you can just copy things without referring to a tag directory, and it won't take up that much more space. I won't be talking too much about branching and tagging now because, as said, they are just implemented by doing copying, and you can read more about them in the book. But if anybody's got any questions at the end, I'll be happy to show you. Alright, so the concepts behind a repository is that a repository sits on a disk somewhere. You get access to it by one of several access methods. Now this slide is called repository setup because it's sort of combined with setup and access of repositories. They're sort of blended together. A repository in Subversion, you can think of it as a database with some config in it. The underlying methods used to store the information in this database, there's one of two methods. It uses a file system method where every database object is a file on the disk. And then there's the old Berkeley DB method where you're actually using an old flat file non-SQL database called Berkeley DB, and that was widely criticized for having corruption problems. What's probably more likely is that people just didn't treat it like a database and do proper database recovery after they had a crash. Anyway, the default storage method for Subversion repositories is now the file system based one. That's been the default for a while, so there's not even any need to specify that when you're creating a repository. I'll be giving a demo on how to create a repository later, but it's a fairly simple thing to do. The more complicated thing to know is how you access it, and so I'll cover those methods now. If you're on the server where the repository exists, you access it via the file system using a file : scheme on your URL, and that simply tells Subversion, okay, go and look up the repository database from this location on the local file system. It's fairly easy, but of course it uses Unix file permissions, and therefore you have to have permission to read and write all the files. And if you write any files when you do a check-in or a commit, and they don't of the right permissions because your UMask was too restrictive, anybody else in the same group as you who thought that they might have access to the files won't. So it's worthwhile being aware of permissions issues with Subversion, especially with the file protocol. This is not recommended because it doesn't use any of the proper user-based or network-based access methods. So even if you are accessing a file on the same server, a repository on the same server, it's better to use one of the following. Okay, so the next method, Subversion does actually have its own wire protocol. To use this, you need to run a program called Svn Serve, which is logically equivalent to the rsync daemon, and you have a URL that starts with SVN, and then you communicate with the Subversion Svn Serve daemon on the server where the repository is, and that means you can check out files from anywhere as long as you have access over SVN protocol to the machine where the repository is. The more commonly used method is Svn plus SSH. This is a bit like how rsync works with SSH. It means that you have to have SSH access to the machine where the repository is. You make a connection using your Subversion client. It then talks the Subversion protocol over a link running over the SSH connection to an instance of Svn Serve that it started itself at the start of the SSH connection, and this then quits when the SSH connection finishes because you just finished your operation that you were doing with Subversion. Now there's two sorts of ways you can use the Svn plus SSH method. And you might say, well, isn't it just SSH? Don't I just have a user on the machine that I'm logging into via the Svn plus SSH protocol? And the short answer is no, you may not. The people who administer the repository might view it as a security risk to give people SSH access. So what they can do instead is provide key-based access. So I'll get to that in a second, but I will tell you briefly how user-based access works. You log in as yourself to the server. You'll either have to put in an SSH password each time, or you'll have to use a SSH agent to retain your decrypted passphrase in memory, or decrypted private key in memory, I should say. And it then lets you make an SSH connection and talks SVN over that connection, and you are manipulating the repository on the server using your user ID. Now what I was talking about before with permissions problems, that's now largely addressed with Svn Serve, so you needn't worry about making files unreadable to other people. And when I say files, I'm talking about files that are used in the repository, not files that you might have checked in. I'm talking about at the database layer in the repository. So I talked about key-based before. If anybody's used something like Bitbucket or even GitHub, you will be familiar that you log in using the user Git, and you have to have all your own SSH keys set up on the server. That's because of something called command forcing. Obviously the ing has, or the ng has been dropped off the end here, but command forcing is a useful SSH tool, which means that when you are logging into a server using a public key, the public key in the authorized keys file on the server that's letting you log in can force a particular command to be run instead of the shell that you would normally get when you SSH to a machine. And to cut a long story short, the command that is forced to be run when you're using the key-based method is a variant on Svn serve which actually specifies a username. And this username is a fake user. It doesn't have to be and shouldn't be a user that's actually present on the machine where the repository is. It's fake, which means it's only used by Svn serve, because key-based starts an Svn serve instance just like user-based, only the command that starts the Svn serve instance is always the same command, and that's in the .sh/authorized keys file on the server. Now, there's a lot of information here so far, so I'm just going to pause and see, does anybody have any questions about this SSH stuff, or about how it differs with the plain SVN protocol? Wait a sec, we got a microphone for James. I'll grab that. Thank you.
You said the file protocol is discouraged, but
yeah,
if you're using SSH, then you pretty much need, assuming other than this command forcing mode, you're going to have write access to the repository anyway on the remote system. So it's basically, isn't that going to be just as secure as using a file-based one?
The discouragement with the file protocol is not based on security, because obviously if you're on the local, logged in on the local machine, you have full access to all of those files in the repository, and you could delete them or be malicious. This one, user-based, you have to trust your users. You have to trust anybody that has a user access to the repository, because ultimately they could just SSH into the machine and do whatever they want anyway.
Right, so the SSH thing is going to be equally secure to the file-based one without any kind, if you're not using a command forcing type arrangement, right? That's correct, although the benefit to Svn serve is it sets the umask properly, and it means you don't accidentally remove permissions on files that should be there. So yeah, as I was saying, that one's not recommended for various reasons, but security is a reason that it's not recommended, and as you say, this suffers equally from that security issue. So talking about the key-based one, that doesn't have the same security issue because you are using a SSH user that does not have a shell, so you can't actually log in, and hopefully we have port forwarding disabled for that user on the server anyway. If you guys are sorting out an issue, I can pause while you do that. Yeah, it's cool. All right. So moving on, there is yet another way to access repositories, and that's via using HTTP. Now, HTTP is an interesting protocol because it doesn't just have GET and POST, it also has additional protocols like PUT, delete, etc. Also, PropFind is another one that isn't possibly even part of the HTTP standard, but all of these additional access methods are used by DAV. DAV is interesting because it's kind of like something like SOAP or whatever, but it's not designed for making method calls. What it's designed for is sending and receiving data and performing operations on things on a server. So in effect, you can think of DAV and REST as being very similar. Anyway, DAV counts as a protocol on its own, even though it runs over the top of an HTTP connection, which means you can run this on a SSL but secured HTTP connection and it will still work. Now, in order to use this, you need to add certain modules to Apache
dav and dav svn. Once you've done that, you can put a few extra bits of magic in your virtual host declaration on your Apache server, including where the repository is, and then you can just magically access your repository via an HTTP URL. And you might think, doesn't that mean the whole world gets write access to my repository? The short answer is yes, it does, unless you prevent dav from using any of the protocols that can write to a repository. This is possible because you have interesting Apache things that let you limit a given HTTP connection to only being able to use certain request methods. All right, so I won't try and explain how that works in detail, but put it this way: if you are using HTTP and you haven't prevented write access to your repository, you want to have some sort of authentication, which I'll cover in a sec, to make sure that only the people who are supposed to get access to your repository can do so, i.e. you make them log in when they're viewing a certain URL. Now, Lite HTTPD has a WebDAV module, but I'm not sure if that has the capability of supporting Subversion, and Nginx is not supported at all. So generally speaking, if you want to use this for getting to a Subversion repository, you would need to use Apache as your web server. Okay, so here's how authentication works. If you're running a standalone SVN serve instance, this is using the SVN protocol that I mentioned earlier. It has its own password file, which means you're using fake users, and you add users and passwords to the file. When everybody makes a connection to a repository using an SVN scheme, it will let them log in if they have a user and password in this password file. With the HTTP stuff that I was just talking about, you'll set up a particular directory in your virtual host so that people can only access that directory if they've logged in using a HTTP basic or digest authentication. And ideally, you'll want to be using SSL for this, because otherwise those passwords could be sniffed over the wire. That's simply a case of adding a directory block with certain things on authentication and where the repository is, and if you want, limiting the request methods for HTTP, but won't get into any more detail. Now, with user-based SVN, this is the one where people are logging in using their own users. It uses PAM, pluggable authentication modules, just like SSH does. So in effect, if people can log in using SSH, they'll be able to log in using SVN plus SSH. And with key-based SVN plus SSH, the users are fake, because the user that you're actually committing to the repository as is specified next to the appropriate key in the authorized keys file. So let's say you've got the public key from users Bob, Fred, and Jill, and you've put them all in the authorized keys file on your server. In the account of, say, SVN, right? Because I remember I said that there is a standard user that everybody uses to SSH in, and it's only which key that they're getting in by that determines the fake user that they're actually logging in to the repository as. Right? Has anybody is anybody here not familiar enough with SVN, so with SSH, that they have no idea what I'm talking about here? Don't be afraid to put up your hand, because SVN plus SSH is a very common method of using repositories, especially public ones, will more likely, as James hinted at, be key-based. Right? If not, I'll move on. Right. So once you've logged in to a repository, so to speak, you can do certain things to certain directories in the repository. Now here I'm actually talking about at the file level, not at that database level behind the scenes that I mentioned. So if you had a tree with 3 directories, X, Y, and Z in it, this was checked into your repository. If you wanted to prevent people from making changes to directory X unless they were in a specific group, you do it by the use of a access control file. This is a fairly simple file that contains paths. It contains group specifications, and it says on those paths which groups are allowed to read and or write to them, which means you can block off entire chunks of your repository so that people can't even check them out at all. This auth SVN access file setting in your Apache config actually comes from dav SVN module, and kind of tells the SVN dav module which file that it should use to say which fake user, because remember I said that HTTP has fake users, but they're actually specified in a .ht password file. So which of those have access is determined by this setting, which points to that access control file. Or if you're using an SVN serve daemon or a key-based SVN plus SSH or a user-based SVN plus SSH, you will use this authzdb setting in the conf directory inside the repository. This is down at the database level again. It's not a file that you can check out from the repository. So you just got to edit that on the server itself where the repository is. This specifies your real for regular user-based SVN plus SSH, or fake for SVN or key-based SVN plus SSH. That determines which of those real or fake users will be able to access which files, as I previously mentioned. Okay, now I think it's probably about time that I try and do a demo here. What I'd like to do is I'd actually like to use a different laptop for this if I could. Is this one going? Doesn't have power though. Is it going to last? Right. Oh yeah, if somebody knows the password for the AV Guy account, please do. Thanks, Luke. Meanwhile, I've got something I need to do here. Say what? I can install that. Let's see if I can maximize this. It's Alt Control Up, isn't it? Oh, F12? Because that's not a normal terminal. Start at another terminal. Yeah, sure. That's readable, so you don't need to make it bigger after the clock. You can maximize it. Yeah, right. Okay, this is how you do a checkout. First of all, if SVN's not installed, this is helpfully how you install it. Oh, AV Guy password again, please. Yeah, cool. Okay, so currently we're installing SVN. The Subversion package on Debian, and I think it's also the Subversion package on Red Hat, contains both the SVN client, the SVN admin administrative tool, and the SVN serve binary. So you only ever need one package to do anything with Subversion. But for Apache, those moddav and moddav SVN things actually come from a separate package, so you don't get them with SVN or Apache, you install them separately. Alright, so we're back to a prompt. Now CO is short for checkout. You only do a checkout once. Does anybody else in the audience want me to increase the font size, or can everybody see it okay? Bigger? Yeah, all right. Yeah, sure. Cool. So what I'm doing now
dear. Maybe we don't have network access. Yeah, good point. Excuse me while I just check out what repository URL I'm supposed to be using. Okay, since for some reason there's a problem with the repository I was going to use, I'll just go ahead and create one. So a simple SVN admin create and then the name of the repository creates a directory called demo that's got a bunch of stuff in it. This is what an SVN repository looks like internally, even with a readme.txt that they put in there for you. So now what I want to do is actually want to check out that repository into a source directory. You actually do have to specify an absolute path within this URL, and the server part of the URL scheme is actually blank. That's why they've got / and then nothing, and then the / for the root directory. Okay, so a newly created Subversion repository has a revision of 0. Remember when I said the repositories have a master version number? So there's nothing in that repository. If I do a ls-a, you'll see that all that has in there is, oh, maybe I better cd into the repository directory. All there is in that directory is a .svn directory. Every directory within a working copy has one of these .svn directories in it. It's worth being aware of, and there's ways to get around that later. I mean, you don't avoid that, you just make it not be a problem. Okay, so I will now demonstrate how to add something. I've created a file in my working copy. Now the difference between a working copy and a repository is you can have multiple working copies that all came from the same repository, and each working copy is simply the place where you do your work. You can create files there. They won't automatically be checked. If I go and do another commit, change the file, and I mentioned that fact. It's now committed the revision. And if I do log, nothing happens, and you might think, well, that's pretty crazy. It's actually a requirement that before you do a commit, if anybody else has been modifying the repository, or if you want to do a log command, you do svn up. That's short for update. So what an update does, you know how when you make changes to your working copy, you can commit them? If other people have made changes in their working copy and committed them to the repository, you have to sort of synchronize your changes, and you don't synchronize with the other people, you synchronize with the repository, and the svn up, or also known as update command, does this. It goes to the repository
and it pulls down the head revision and makes any changes to your working copy to reflect the changes that have been made in the repository since you last did a commit. Right? So really it's just a case of it updates all your working copies to the latest repository revision. If you happen to change any of your working copies since you last did a commit, and they were also changed on the server, Subversion helpfully merges those changes that came from the repository with the changes that you made in the working copy, and normally it'll all work. You just have both sets of changes in the file. But if both you and, say, Jill changed the same line in the same file, Jill checked it in, you made your changes, and then you tried to do an update to get the revisions from the server, there will be a conflict. And you have to manually resolve merge conflicts yourself, and then you can tell Subversion that, yep, it's all resolved, and it can then, because yeah, basically you can't do further updates or commits when you've got files that have got a merge conflict. That's not really something I can demonstrate quickly here, so I won't. I'll just tell you, don't panic if more than one person has been making changes, because they'll usually get merged successfully. But you know what I was saying before about multiple working copies and one server? Before you do a commit, you have to do an update, because if you have anything that you're committing to the server when your local working copy thinks it's committing, say, to revision 3, if the server's now at revision 5 in the repository, you'll get problems. It'll give you weird error messages. So if you ever get any weird error messages when you try and do a commit, just do an SVN update to pull down any changes, and then your commit should then succeed correctly. And just remember that if you try and do a commit and it fails, you haven't lost those revision descriptions. They're just saved in a file called, I think, yeah, it's not saying it there on the screen, but it's like svn.tmp. And it's not in the current directory, it's in the directory that you were checking in, it's committing. So that's that, you know, if you know to look for that file and it's not in your current directory, just try looking for the file you tried to commit. Because you don't have to commit the whole repository at once. You can commit the changes that you've made in one particular subdirectory of your working copy, and those changes will be the only ones that go to the server in this particular commit. You'll still have a new revision number, but if you then do a commit on those other directories, they will form a new revision on the repository in the server. So you don't have to think of all your files having the same revision number. Just think of individual commits having their own individual revision numbers, no matter where they came from in the repository. And then you'll probably start to realize, hang on a minute, this isn't all that different from Git after all. It is, but it can be useful to try and have a idea in your mind of how to work it. Okay, I'm just going to switch back to the presentation, and so that was our demo. Right, now I'll just skim these because I actually covered most of it already. You only do a checkout once. That happens when you initially create a working copy from a particular repository. It's talking about multiple working copies, that's done. Update before commit, that's done. Revert. Revert is interesting because it doesn't get new changes from the server. What it does is it undoes changes that you did since the last checkout or update. Because Subversion actually in those .svn directories maintains unmodified copies of all the files that you have checked out in the first step, and it actually updates those when you do a successful commit. So if you decide, oh, I didn't want to make those changes, you do a revert on a particular file and it will restore it to how it was when it was last checked out. But it won't restore it to the latest server version. If you want to do that, do a revert, then do an update, and then you'll get the latest latest version of that file from the latest revision on the repository.
Now you can actually set properties on files in a Subversion repository. For instance, there might be certain files you don't want to commit, and instead of only adding specific files, you might want to add a whole tree, but then mark certain files as do not check this one in, or because check in and commit mean roughly the same thing. But there's also other things that the properties can do. You can even have custom properties if that's useful for you. Now, you know how I told you about those SVN directories, and whenever you do a checkout, you'll get a directory that's full of these subdirectories. If you don't want that, you can check out something that isn't a working copy. It's just like a dump of all the files at the latest revision from the repository, and that's an export. That will give you a clean working copy. Now, you can't actually do any mods in there and make any changes and commit them, because it doesn't have the SVN directories that let the Subversion tool do its work. So that's export. Pretty sure I already covered the demo for this in my other demo, but does anybody want me to go into any more depth on any of this stuff? Nope. Okay. Right, so I said that you have to add files before you commit them. This really just flags them for addition in the local database within your repository, within your working copy, so that when you do a commit, it automatically scans the files, looks in the .svn directories for the little file that says what the status is of the various files that you've got, and the ones that are scheduled for addition, or the ones that it can see have been modified. Because after you modify a file, you remember I didn't have to do anything special to get it to be included in the next commit. It just automatically does an internal diff between your file on the working copy and that that fresh copy that it maintains in the directory. So it automatically knows which files you've changed. And if you add them and they weren't already part of the repository, then they'll be added on the next commit. Revert is useful because it doesn't just revert files back to how they were on the last checkout or update. If you have scheduled a file for addition and you don't want it to be, you don't delete the file, because then it will just say, oh, we've got a file scheduled for addition, but it's gone, and then your commit will fail. What you do instead is you revert the file. Now, this has a different behavior when you're reverting a file that was scheduled for addition, because it just removes the addition flag. It doesn't actually change the file in any way, because if you think about it, there's no golden copy in the .svn directory that it would be able to replace it with. So that's what revert does, is it removes the add flag on files that haven't actually been committed yet. Now, revision descriptions are important. I can't stress this highly enough, because when you're looking at a Subversion log, every revision in the repository that applies to the current directory, and I know you can't see it now, but over here it's saying that revision 1 had a garbage string for the revision description. Revision 2 says change the file, because a log will tell you the log entries for the current directory and any files in it. It's not recursive though, I don't think. So yeah, logs will give you insight onto why changes were made, and why changes were made is just as important as which changes were made. And it's worthwhile mentioning the paths of those files as well, because somebody can do an svn log-v and see the files that were changed in a commit, even if you didn't mention them in the revision description. But why make them? Why not just mention it? And you should also describe the broader purpose of the commit, like which bug it fixed or what have you. And because you either have real or fake users, when you do commits, you know who did the commit. And there's a really interesting command that I like quite a lot called svn blame. What it will do is it will go through any given file in your working copy, and it will tell you exactly who was the last user who changed each individual line in the file. So if you want to know who made a given change, you don't have to crawl through the diffs. You can just do a blame, and it will just show up as this person was the last person to change this line in the file. Very handy. But it's no substitute for revision descriptions. Now, in your revision descriptions, if you're doing any merging, you've got to describe which revision
was the source of the merge, so that if anybody wants to do a merge later, then they know what's already been merged. And merging's a tough one with Subversion. I'll talk about that if we have time later. I'm going to claim that I've already done this demo because we're running short of time. Okay, now there's a few kinds of backups with Subversion. There's no demo for this one, but there's several reasons why you need to do backups. One is if you get any repository corruption, obviously that's a problem. Secondly, if you realize that people committed stuff to a repository that they shouldn't have, sure, you can delete those files and then do a commit, and they will be deleted out of the repository, but they'll still exist as objects in the repository. So if someone deletes, if someone accidentally commits a 100 meg file and you don't want that in the repository anymore, there's no real way to actually go and delete that out of the database layer in the repository. So what you should do then instead is restore from backup and then replay any commits that have been done since then. There are two sorts of backup. There's a full backup, which you can think of as a copy of the repository directory and everything in it, but there's only one safe way to do that, and that's with the Svn Hot Copy Script. What this does is it makes sure that when it copies the files, it copies them in a set order. That means if there's any changes being made to the repository during the copy won't include those changes, and all the files in the database layer of the repository will be consistent. So that's a full backup. There's also incremental backups. These are known as dumps in Subversion, where you can basically say, I want to get all of the changes made between, say, revision 1 and revision 5 in a repository, and dump them. And what you get is this weird text format which contains all of the changes, and these are relative dumps, like each dump is relative to the one before. So dumping 1 through 5 is the same as individually dumping revisions 1, 2, 3, 4, and 5. Each dump requires the one before to have already been replayed into a new repository in order to itself be able to be replayed into the repository, unless you're specifically wanting to skip that restoring revision 3, because that was the one where the 100 meg file got committed to the repo. And if anybody's interested, I've actually written some scripts that do full and incremental dumps of Subversion and only keeps the incrementals that you need since the last full. But that's sort of a work in progress, however it is operational. And I would give you a URL to be able to check that out, except for some reason my repository isn't working, because I've got a read-only HTTP repository that I was going to use for my demo. That's where I put all my tools and scripts and dot files and such. And make sure you do test restores, because unless you restore your backups, you're never going to be 100% sure that A, you'll get back what you thought you were backing up, or that B, your backups were working in the first place. There's been places where they've been doing tape backups and haven't been doing test restores, and one day when they did need to restore the data, they pulled the tapes out of the tape library or tape safe or wherever they were, and they saw that the plastic strip of the tape was clear because the tapes had been used so long that all the iron oxide had worn off them. So yeah, test your backups. It's very important. Sometimes people do that. They just swap the tapes and they don't check to see whether or not the tape drive's even throwing an error.
Thank you. Is that coming through? You mentioned something that was shocking to me, that maybe the repo would get corrupted.
Mm-hmm.
Is that something that's...
Hang on a second. Is it on?
Is that something that's common with these inferior revision control systems?
Well, there's been people who've said that Git can mash their data. Oh yeah, sure. Apparently we didn't get that on the audio. So I'll try and rephrase the question. Correct me if I don't get it. It was something like, so is it possible that you would get repository corruption in inferior revision control systems?
Well, I think the question is, why would it get corrupted?
Usually it can be because of things like power failures, or maybe there was a bug at some point that's since been fixed, but
the bug might not have been fixed at the time that you made your last commit, which means there could be some lingering cruft in the repository that causes a problem down the track. Why files get corrupted could happen for a number of reasons. Trying to figure out why they can get corrupted and avoid that is not the whole solution, because backups also save you from human error. But yeah, as I hinted at earlier, the main reason Subversion repositories used to get corrupted was because you had a Berkeley DB system as the underlying object storage method in the database layer of the repository, and that was more prone to corruption than a file system based object storage method. Yeah. Okay, so yeah, all right, I'll skim merging. Merging is what happens when you have branches, and a branch is where you have two parallel sets of changes that are sensible and similar, but one of them's a bit different because maybe that's the one where it has the custom mods for the picky customer. Maybe down the track, you might want to merge those changes in from the branch for the picky customer into the main branch that everybody uses. Subversion merges allow you to automatically take the diff between revision A and revision B in a given branch. I'm using letters there because the numbers might be big, and anyway, I don't want to try and think up examples. Takes the diffs between A and B and then applies those differences, right? So any files that were changed between A and revision B, and applies them to somewhere else in the repository. Obviously, you're expecting there to be the same tree of files in this other branch in the repository, and it will then bring all of those files with their own changes still intact, up to date with the changes that you made in the picky branch. Right? So really it's a way of diverging changes on different branches, which you then sort of plat back together and make a common branch that includes two sets of changes. That's what merging is for. Subversion merging, it has a merge command, but it doesn't do things like automatically keep track of which changes have been merged already. You need to keep track of that yourself in the revision description. So you might say, I'm doing a merge that has the basis of revision 1, 2, 3, 4. And that way, when you do a merge in future, it will actually tell you, when you do an SVN log to see what's been done to this branch, you'll see that particular sets of changes have already been merged, and so that you only need to merge changes in revisions more recent than the last one that was merged. Peter, you had a question. Wait a sec, I'll get the mic for you.
Isn't it the case that the Subversion people have been doing work upon their merging algorithms, and their intention is to make it a lot more automatic, a la the ease of merging in Git and similar DCVSs?
I would hope so.
You're describing basically saying that the merge command does the wrong thing by default. What you're saying
It doesn't just do the wrong thing by
it'll do the
default,
wrong
it
thing.
always does the wrong thing. The merge command, really you have to specify the start and end revisions of the merge, which means you're the one responsible for invoking the merge command correctly, unless you're using a more recent version of Subversion that Peter hinted at, which automatically keeps track of this. So if you run the merge command wrong, you are responsible for the wrong results. That's what it comes down to.
Sounds pretty useless.
It's not useless if you are relatively diligent in saying what you've done already when you check in the merge, because a merge usually will alter your working copy, and you can then have the chance to review the results of the merge before you actually commit that to the repository. So when you do your commit, you will say, I merged revisions 1, 2, 3, 4 through 1, 2, 3, 7 from the other branch, and anybody who does a merge in future can look at the log of the regular branch and see, right, this has been merged already. Have there been any other changes that I want from the other branch? If so, I'll start the merge point at the next revision after that and continue on from there.
Right, but that's generally not enough once you're doing merges between more than two branches.
What if you, every time you did a merge, said which branch you were merging from and the range of revisions that you merged,
you could check back through those, and if you are merging from 3 branches, you can look back through the logs to see all the last merge from each of these 3 branches that were mentioned in the log for the current branch.
So what I mean, let's say that you've got branches A, B, and C.
Mm-hmm.
You're in A, you've
Yep.
merged from B,
Yeah.
and then you want to merge from C,
Mm-hmm.
and that branch C had also merged from B. So it's got, so C has got some of the changes from B, which you've already got, and you want to merge C into your branch.
In that case, you'd probably have to be pretty careful about making sure exactly which revisions from C you are merging. Merging is not to be taken lightly, which I already put in the slide. But you're right, there are what I would call degenerate or pathological merge situations that mean that if you're doing stuff that's really complicated, Subversion is probably not your tool. That's why they invented DVCSs. I'm not here trying to say that Subversion is the preferred tool or the default tool or the tool you should use until there's an absolute reason why you can't not use something else. I'm just saying it for what it is, which is a simpler way of doing things that may be sufficient in some cases. Happy? Cool. Yeah, and as I said earlier, merge conflicts, even if you are not doing merging, even if you're just checking stuff out from the server that other people have changed, and there's conflicts in files on similar lines that you have changed in your own working copy, that's still called a merge conflict and you still have to resolve it. But these usually aren't difficult because it will give you 2 chunks. It will have a start delimiter, the chunk from the upstream revision, which comes from the repository, a separation delimiter, and it will have the chunk of the file that was in your working copy, and then a end delimiter, and you basically just combine those 2 chunks together in whatever way you see fit, remove all the delimiters, mark the merge as resolved, and then you can do a commit and it'll all just work. Vendor branches, I'm not going to try and talk about them now. They're mentioned in the book. Speaking of which, we're now at the conclusion of the talk. There is a thing called the Red Book. It's an electronic version of a published book that was called Version Control with Subversion. It's svnbook.red-bean.com. That says com over here. And you will learn everything you ever want to know about Subversion from reading that book because it's extremely comprehensive. If you have any problems with Subversion, feel free to subscribe to the plug mailing list and post a question. And if you really get stuck on something, feel free to give me an email at this address and I can probably help you out because I've been doing Subversion stuff for a few years. Right, any final questions? Nope. Right. Thanks.